Hello again and welcome to the next video of Section 5, Environment Physics. In the previous video we've learned how to create an environment. In this video we'll discuss more about environment physics. The main problem with our level as it stands is that it lacks interactivity. Specifically, if we dragged and dropped a player object to the level and pressed play on the toolbar, the player would drop through the floor and walls because the foreground texture isn't recognized by Unity as a solid object. It's just a texture, and exists only in appearance, not in substance. In this section we'll correct this using physics and colliders. To get started, we'll create a temporary layer object. Not the final version, but just a temporary white box version used only for testing purposes. To create this, generate a capsule object in the scene by navigating to Game Object, 3D Object, Capsule from the application menu. Set the Z position of the transform to match the foreground texture. For me, this is -2. Once generated, remove Capsule Collider from the object. By default, the capsule is assigned a 3D collider, such as the Capsule Collider, which is useful primarily for 3D physics, but our game will be 2D. To remove the collider, click on the cog icon on the Capsule Collider component in the Object Inspector and choose Remove Component from the menu. To make the object compatible with 2D physics, add a Circle Collider component by choosing Component, Physics 2D, Circle Collider from the application menu. Once added, use the offset and radius settings on the Circle Collider component in the inspector to adjust the size and position of the circle in relation to the capsule object in order to approximate the feet of a player character. In aid you in positioning the Circle Collider more easily, you can switch the Scene Viewport mode to Wireframe and 2D if needed. To do this, use the 2D toggle button and the Scene Render Mode drop-down button in the Viewport toolbar. Next, to make the Circle Collider work with 2D physics, add a Rigid Body 2D component to the capsule. To do this, select Component, Physics 2D, Rigid Body 2D from the application menu. You can confirm that this has worked by previewing the game in play mode. When you click on the play icon, the capsule object should fall down and through the foreground floor under the effect of gravity. Now it's time to configure the foreground texture to work as a unified whole with physics. Right now, our test player character falls through the floor, and this is not what we want. To fix this, we'll need to add a collider in the foreground environment. One method for this is to use Edge Collider 2D. This lets you draw out a low polygon mesh collider around your ground image manually, approximating the terrain. To get started, select the foreground in the scene and then choose Component, Physics 2D, Collider 2D from the application menu. Doing this will add an Edge Collider 2D component to the foreground object. By default, adding an Edge Collider 2D appears to have little effect on the selected object or any other objects, except for a single horizontal line drawn across the width of the scene. Of course, our terrain isn't simply a straight-edged surface. Rather, it has elevations, bumps and platforms. These can be approximated closely with the Edge Collider 2D component using the Collider Edit mode. To access this mode, click on Edit Collider button from the Object Inspector. When the Edit Collider mode is active, you can reshape the collider to conform to the terrain. Let's focus on one such area as the bottom right-hand side of the terrain. By moving your mouse cursor over the edge points of the Edge Collider, the green line, you can click and drag to reposition it. To approximate the bottom right island of the terrain, click and drag the rightmost edge point to the right-hand side of the scene. Next, click and drag the left point of the collider to match with the leftmost of the right-hand island. Now that the left and right edge points are positioned, let's add some additional points on the line between to reshape it, conforming to the right-hand island. Move your cursor anywhere on the line, click and drag to insert a new point, and reposition it to match the island. Repeat this process, adding additional points to reshape the line as needed. You now have a fully shaped line that matches the terrain's rightmost island. Having created this, exit the Edit Collider mode by simply clicking on the Edit Collider button again from the Object Inspector. To create colliders for the remaining islands of the terrain, add a new Edge Collider to the same object. You can then add any number of Edge Colliders to a single object. and each collider should be used to approximate the topology of a single, isolated island in the complete terrain. Multiple edge collider components are now added together to a single foreground object, approximating the complete terrain for the scene. We can now test play collisions against the player capsule object by pressing the play icon on the toolbar and seeing how the capsule reacts against the terrain. This time the capsule will collide and interact with the ground as opposed to passing through. This confirms that the terrain is configured appropriately with the physics system. Congratulations! In this section we've created a complete terrain for a single scene using edge collider components. This terrain not only fits the screen and appears as intended, but acts as a physical obstacle for the player character and other physics-based objects. Of course, so far we've been using a rough approximation for the player, and now it's time to expand upon this. In the next video we'll learn how to create a player.